Good morning all. I am Mrs.Y.Helan Cynthiya, Assistant Professor of Department of Computer Applications. So today I am going to deliver the topic graph traversals. The content for today's topic is graph traversals, its definitions and the types of traversal algorithms. Particularly today I am going to teach only the depth first search algorithm and its stepwise explanation and the working of DFS. Graph traversals. Before moving on to the graph traversals, actually the graph is a set of ordered pairs which consist of vertices and edges. So G of V comma E is the representation of graph. So V represents the vertices and E represents the edges. So E is the edges, which is the connection between the two vertices. So this is vertices 1 and this is vertices 2, and the connection between these two vertices we will be calling it as edges. Moving on to the graph traversals. So graph traversal is a method to search nodes in a graph. The traversal of graph is used to decide the order for node arrangement. So the graph traversals, the main purpose of using it is to find the shortest path in the graph, and this contributes the arrangement of the nodes in your graph. So it actually searches for edges without making a loop, and then after traversing the graph you will get a final output, that is a spanning tree, a tree with minimum number of edges between sources and destination vertices. So we will get a spanning tree. In all these traversal algorithms we will be getting the spanning tree which will reduce the looping in our graph. So next the types will be two major types. One is the depth first traversal, the other one is breadth first traversal. Depth first traversal, it explores the vertices deeper manner, like from the source vertex it goes deeper into the nodes, ignoring all its siblings and children nodes. So for example, if you are having a graph like this, so the depth first traversal will move towards deeper manner. So it won't consider their sibling nodes. These nodes are called it as sibling nodes. So these will not be taken into consideration for depth first traversal. So once the nodes which will be at the deeper node, that is to the leaf node, it will be calculating the path, and then it again traverses back and reaches its sibling nodes. So this is the depth first traversals. And the next one, so it is implemented using the stack data structure and the recursion technology. So where if any node is unvisited in the graph, and the nodes which don't have the nodes to be visited, then it backtracks to the previous node and visits the remaining unvisited nodes. So the recursion will happen there. We use the stack data structure. So while stack we are using is the insertion and deletion will happen at the one end, that is on the top of the stack. So DFS is also called as an in-depth search method. And next, moving on to the breadth first search. So it explores the vertices in the level manner. Okay, so for breadth first search, if you are having the vertices like this and you have the edges like this, so it will explore all the vertices in this format. So it will finishes the vertices in the same level, and then it will move on to the next level. So this is the breadth first traversals. It is implemented using the queue method, queue data structure. So where the insertion will occur at the rear end and deletion will occur at the front end. So for the queue we can take an example, paying a bill in a bill counter. So where the person who is standing at the front will be served first and will be moved out. So that concept will be applied in queue data structure. And next we are concentrating on depth first traversal, and here is, as said earlier, the definition for DFS is it searches the nodes, it searches the path in a deeper manner. We will see the stepwise explanation for how to traverse a graph using DFS. So step 1, we need to create a stack with the number of vertices. If your graph contains 8 or 9 vertices, your stack will hold 9 elements. Next, in the second step, we need to consider any one vertex as a starting vertex and we need to push it into the stack. Remember, the stack will be, in the stack the elements will be inserted at the top of the stack. In step 3, we have to push the non-visited adjacent nodes to the top of the stack, and then we will mark them as the visited, and in step 4 we need to repeat the steps, step 2 and step 3 until all the vertices which is at the top of the stack will be visited. In step 5, if no vertex is left, we need to go back and pop the element, so where the backtracking occurs here. And in step 6, all the steps 2, 3 and 4 will be repeated when all the vertices in the graph are visited, and finally the stack will get empty and we will produce a spanning tree. So here we can see the working of a DFS. Let's consider this graph. It has the vertices, total number of vertices here it is 7, and this is a stack with a 7 space allotment. So in this first step I am considering the vertex A as the starting vertex and I pushed into the stack, and in the second step I am going to visiting it. After that I am going to look after its adjacent nodes. So here my adjacent nodes for for A is B, E and D. So for this DFS traversal, since the vertices has the values A, B, C, so we can go in an order, alphabetical order. So it is decided by your CPU whether it has to choose which order. So in case if the edges carry any weight, like it carries time or it carries the distance value, it prefers the shortest distance first. So for general understanding of DFS, we consider it in an alphabetical order. So since A contains B, E and D as its adjacent nodes, we consider B now. So B is next adjacent node to A. So now I am pushing this B to the stack, and that is B will be at the top of the stack. Next, in the step 3, we will be looking for another adjacent nodes from B. So from B, A, C and E are adjacent nodes. So since A is already visited, we know we need to ignore the visited nodes. We need to concentrate on the not visited nodes. So we concentrate on C and E. So in alphabetical order, C comes first. So we are moving to C and pushing the C to the stack on the top. Next, from C we are having 4 adjacent nodes, which is D, E, F and G. Since B is visited already, so E comes first in an alphabetical order. So we are going to the node E. So E will be pushed into the stack, and from E, so all these green indicates the visited nodes, and from E again it checks for an adjacent nodes. Since all the 3 nodes A, B, C are already visited, it has 2 unvisited nodes, that is D and F, and in an alphabetical order it moves towards D. So when reaching D, it will be pushed into the stack. When at the D, it will explore the adjacent nodes here. So since all the nodes connected to D is already visited, the backtracking happens here. So when backtracking happens, the element which is at the top of stack D will be popped out, and it will be traversed back to the previous state, that is E. Now E becomes your top of the stack. From E, it explores the F vertex which is not visited, and now the path will goes from E to F, and F will be pushed on to the top of the stack. And after visiting the F, again it will look for the adjacent nodes. Since E and C are already visited, it moves to the G vertices which is left unvisited. So now after visiting G, so G will be pushed into the stack, and once all the vertices in your graph are visited, now the elements from the stack will be popped out. So after finally we will get a spanning tree. So after all the nodes are visited, the elements will be popped out one by one. So the result of this DFS algorithm will be the spanning tree, and this is your path from A to G. So this is the spanning tree which gives you the minimum number of edges between the vertices, and the path from DFS traversal would be A, B, C, E, D and F and G. So, the path which have been generated by DFS traversal is A, B, C, E, D, F and G, and recursion occurs at D. So, thank you for this opportunity to give me this lecture. Thank you.